Hello and welcome. In this video, we're going to look at engineering notation. So previously we looked at scientific notation and we said that that was going to represent large numbers and small numbers in a convenient way. And engineering notation is going to do the same thing, but this time we get to use letters instead of times 10 numbers. So we are at base right now. That's our 0 location. 2 times 10 to the 0 gives us 0, and that's our base. So we got 2 at the base. And so if we move towards the positive side, our left here, we see that we can go up to positive 3. It moves in groups of 3. It can't go to the times 10 to the 1 or times 10 to the 2, but it can go times 10 to the 3. And then we're going to represent that with a k. Instead of saying 2 times 10 to the positive 3 or 2,000, we can say 2k, right? 2 kilo. We can move that back even one more stage here, and we can represent all 6 zeros here as an m. Instead of saying 2 times 10 to the positive 6, we can say 2m or 2 mega, right? And it's a capital M, representing that very large number. Right, we can keep going back here. We can get to the giga stage, and that's times 10 to the positive 9, and we can represent that with a 2g or 2 giga. Then we move back one more here, and we can do the times 10 to the positive 12, right? That's a lot of zeros there, but we can just represent it as a 2t or a 2 tera, right? Terabyte, that kind of thing. And we can go the opposite way as well. So if we're back at 0 here, we can go down to the negative 3 location, and that's going to be a tiny little m, right? And that's going to be our negative 3. 2 times 10 to the negative 3, that represents 0.002, and we can write that as 2 little m, right? 2 milli. We'll use that quite a bit for current values. We can keep going back here, and we can say that 2 times 10 to the negative 6, or 0.000002, is going to be 2 micro, this little u with the front end tail on it. A lot of times we can just put in a u for that symbol as well if we can't find that micro symbol there. We can keep going back here and get to times 10 to the negative 9. That's a really small number. It's got 9 zeros in front of the 2 there, and so we're going to call that nano, right? It's 2 nano. Nano is negative 9. You'll remember these after a while. So we keep going back here and we get to pico, right? That's got a lot of zeros in front of it. It's got 12 specifically, and that's going to represent our 2 times 10 to the negative 12, and we'll call that 2 pico. And a lot of times we see this as basically 0. If we see a pico number in there, it's so darn small that we expect it to be almost 0. So when you see pico amps or pico volts, you'll imagine in your head that that is about 0. That's what we associate with 0. So we're going to move these digit here into engineering notation. So we can move it back 1, 2, 3. That's the first spot we can put it. So we can technically leave it right there, right? We can say that we have 0.2625. And since it's back to the negative 3 from its 0 location, we can put an m here. Right? That'll be our milli. And we can keep going if we really wanted to. We can go back another 1, 2, 3 locations and place a decimal point there. And then that same number is also equal to 262.5 micro. Right? We can do that with the big numbers too. Our decimal point is right here. That's our 0 location. So we can go forward 3, 1, 2, 3. We can place it right there and say that that's our positive 3. So we can have 4,650 kilo. Right? Instead of that times 10 to the positive 3, we can keep going. We can go 1, 2, 3 more here and put our decimal point right there. And we can say that we also have 4.65 mega, capital M. Right? That's a really big number. Anytime you see those capital letters, you'll see that they are very large numbers. And a lot of our lowercase numbers are going to represent smaller numbers. So this last one here, we'll put a decimal point here. We can move forward 3, 1, 2, 3. And this is kind of unique from the other ones, right? Now we have 2 digits in front. We can say that that's 75.5, and since we moved forward by 3, that's going to be our k location. So remember, engineering notation can have 3 digits in front of the decimal point, where scientific notation could only have 1 digit in front of the decimal point. But also, engineering notation can only move in groups of 3, and that is how we get our letters for each of the variables that we want to represent. Okay, let us know if you have any other questions.